Lewis structures are a method that chemists use for showing the location of the electrons in an atom or molecule. Lewis structures focus on the number of valence electrons, which are the electrons in the outermost shell of our atom. We write the atomic symbol in the center representing the nucleus and all the inner electrons, and we draw the valence electrons around the outside. So for nitrogen, we have 5 valence electrons, and we draw 5 dots around the center of, or around the symbol of nitrogen. When we start putting them together to make different compounds, if there are electrons found between the elements, these get represented as bonds or as drawn as straight lines in the molecule. Any electrons that are specifically on one atom are drawn as dots. When we draw our Lewis structures, we write the elemental symbol in the center and put an imaginary box around the outside. When we start to add our valence electrons, we put 1 electron on each side of the box until we have 4, and then we start pairing them. Those paired electrons are what we call lone pairs, and they are not involved in a chemical bond. If there is a single electron on a side, that is called an unpaired electron. Our electrons will want to eventually form bonds, and if they are shared and located between the 2 elements, this is what we call a bonding pair. The electrons that are actually involved in the covalent bond between 2 atoms. When we have a bonding pair of electrons, we typically draw it as a straight line representing that bond. Lewis structures will only use valence electrons. So remember, the number on the periodic table will tell us the number of valence electrons. Based on its position, we know the number of electrons. We place each electron as an unpaired electron, up to 4 on each side of our imaginary box, and then we start pairing electrons. Let's draw the Lewis structures for the following atoms. Carbon is located in group 4 or group 14 of the periodic table. It has 4 valence electrons. So we would start by drawing a dot on each side of the carbon. Because it only has 4, we have 4 unpaired electrons. For nitrogen, it's in column 5 or column 15 on the periodic table. We put 1 dot on each side, which gives us 4, and because nitrogen has 5, we have 1 lone pair and 3 non-bonding electrons. Oxygen is in column 6 or 16, which has 6 valence electrons. So we start drawing 4 on each side, and then we have 2 lone pairs and 2 unpaired electrons. Fluorine is in column 7 or 17. So it is going to have 7 valence electrons, which gives it 3 lone pairs and 1 non-bonding electron. This does give us an idea of how many bonds the atom is going to want to make. It's going to prefer to make bonds to those unpaired electrons. So fluorine would like to make 1 bond. Oxygen is going to want to make 2. Nitrogen is going to want to make 3, and carbon is going to want to make 4. This is the preferred way that it likes to bond, but it is not guaranteed. Here's some for you to try. See if you can decide and draw the Lewis structures for the following atoms. Silicon has 4 valence electrons, 4 unpaired electrons. Phosphorus has 5. Sulfur has 6. And chlorine has 7. Common bonding patterns are the trend and show us how many bonds and lone pairs certain atoms prefer or tend to have. So if we are in group 4 is going to prefer to have 4 unpaired electrons. If we're in group 5 is going to prefer to have 1 lone pair and 3 unpaired electrons. Group 6 has 6 valence electrons and it's going to prefer to have 2 lone pairs and 2 unpaired electrons. And group 7 is going to prefer to have 3 lone pairs and 1 unpaired electron. This helps us to decide how many bonds an atom would prefer to have. Just like our ionic compounds, all elements want to have 8 electrons in their outer shell. With covalent compounds, the way they do that is they share. Chlorine, with 7 valence electrons, needs to share 1 additional electron in order to have 8 in its outermost shell. When they share that unpaired electron, then each chlorine is able to count that shared electron in its outer shell and have 8 like the noble gas configuration. The circles show the electrons that count towards each atom. The shared electrons are now a bonding pair. Those 2 shared electrons form a single bond. So 2 electrons for a single bond. Oxygen, which prefers to have 2 lone pairs and 2 unpaired electrons, needs to share 2 additional electrons in order to have 8. So those 4 shared electrons become a double bond, which consists of 4 electrons. Nitrogen, which has 5 valence electrons, needs to share 3 additional electrons in order to form that 8 electrons in its outermost shell. So those 6 shared electrons between the 2 nitrogen is a triple bond, which both share and count towards each nitrogen. So single bonds are the sharing of 2 electrons between atoms. Triple bonds are the sharing of 6, and double bonds are the sharing of 4 electrons between